phosphagen system, as I already talked about it, I once again repeat that it provides energy for muscular contraction at the onset of exercise and during short term high intensity training. So, phosphocreatine when it splits, then enzyme is creatine kinase, then it takes one phosphate out of the creatine and adhere to ADP or diphosphate forming triphosphate. And example is the sprint, jumps, vertical jumps, Olympic lifts. PC store is important in the muscle and are limited, hence the system can provide energy for short period of time, around 10 seconds. If you see the 100-meter running, then 100-meter running, the first phase when you are off the block is the drive phase, which is drive phase. The second phase is the maintenance, which is also called the acceleration phase, which is up to 30 to 40 meters. Then 40 meters to 75 or 80 meters is your maintenance phase, and the third phase is your deceleration phase in 100-meter sprint. Once you have a proper creatine store in the muscle, you can prolong the maintenance phase, which is up to 70-75 meters. You can push it to around 80 meters or 85 meters. So, this depend on the faster rate of ATP or ADP rephosphorylation or the production of ATP, which can directly allow you to perform better. So, anaerobic glycolytic system involve the breakdown of glucose glycogen to bring 2 molecule of pyruvate, also called pyruvic acid, and lactate. Then this process involve a series of enzymatically catalyzed or coupled reaction. Glycolysis occur in the sarcoplasm of the muscle cell, produces a net gain of 2 molecule of ATP, and if the glycogen breaks down, then glycogen breaks down to glucose 1 phosphate and then turn to glucose 6 phosphate. So, the investment process ATP is not required when it breaks down to glycogen to glucose 6 phosphate because it convert to glucose 1 phosphate, which is not energy dependent. So, in that the glycogen in the glycolysis process, when it happen, it produce pyruvate, then the 3 molecule of ATP is the net gain, whereas in the glucose, when it comes and break down to pyruvate, then the 2 molecule of ATP. So, 1 molecule of ATP increase when the glycogen breaks down to pyruvate than glucose break down to pyruvate. So, fate of pyruvate and lactate, the low oxygen, when the system is low in oxygen, the pyruvate is converted to lactate and the enzyme is lactate dehydrogenase. So, the lactate shuttle supplies fuel to the heart and the slow fiber. So, lactate converted to glucose, and this process is of course lactate is one of the major fuel for heart, because the fuel system in the heart is omnivorous. So, there are fat can produce the major energy for running the energy for giving the energy for heart muscles and cardiac muscles. Even the lactate can give one of the major fuel for heart muscle. It is the marker of high intensity activity, that lactic acid system. So, here we can see the glycolytic pathway. The 2 NAD is reduced to NADH. So, the NAD, the oxidation process takes place in the glycolytic process. We get 2 NADH, and the 2 NADH, when it pyruvate is converted to lactate, that NADH is used and the reductive through oxidative reductive reaction the NAD is formed. Now, anaerobic glycolytic system, here is the system where you can see the glucose burned down to glycolysis, and the net gain is 2 molecule of ATP, as I already talked about that. In the pyruvate, when the pyruvate is formed, then the pyruvate is there is a linked reaction, or the oxidation of pyruvate converted to acetyl CoA, where again that one carbon is splits off, and the acetyl CoA is a 2 carbon molecule. From glucose is a 6 carbon molecule, converted to pyruvate is 3 molecule of 3 molecule. Then one carbon is again splits off through carbon dioxide is produced, decarboxylation, and then it converted to acetyl CoA. And once the acetyl CoA is formed, that acetyl CoA enter into the Krebs cycle, and in the Krebs cycle also there are 6 NADH and 2 FADH2 is formed in the Krebs cycle. So the total, if you see calculate, and 2 ATP and 4 CO2 is generating in the Krebs cycle. So if we see the how many numbers of ATP is produced in the Krebs cycle, we can see it is 32. How the 32 is developed, the NADH, each NADH 2.5 ATP is generating from one NADH, and 1.5 ATP is generating through one FADH2. So, and the 2 ATP is here in the Krebs cycle, and 2 ATP in the glycolytic process. So, if you add all these things, the total the number of ATP you will find the 32 number. So, when we talk about the aerobic system, so aerobic system where it is important that it is how long you can continuously you can do the activities. For that, the VO2 max is important, the maximum oxygen uptake capacity. It depends on your cardiac output and maximum cardiac output and your AVO2 difference. So, in short term activity, as we have seen, the energy is coming from ATP, CP and lactic acid system. In long term activities, obviously the it depends on your ability to take oxygen continuously for a longer time, which is aerobic endurance of the VO2 max. The VO2 max depend on arteriovenous oxygen difference and the cardiac output. If you multiply these two, you will get your VO2 max. Then the further longer duration, it is important that what is the percentage VO2 max you are running the race, not the absolute value of VO2 max. What percentage, if somebody is running with a low percentage of VO2 max in the major portion of the races compared to the other runner, then definitely the success of that runner would be much more. So, the percentage of VO2 max plays an important role when the duration is 21 to 1 hour. Then when the duration is further more, which is obviously marathon, then what is more important is percentage of VO2 max, and the percentage of VO2 max is influenced by the liver and muscle glycogen store. So, supplement is very much required. Even the hydration is very important thing which can influence the percentage of VO2 max. So, in a nutshell, I just wanted to give you the idea that from the aerobic also there are moderate time, that is one maybe around less than 60 minutes, more than 60 minutes, and the ultra marathon or the marathon which is more than 2 hours, 2 hours to 4 hours, where the supplements and the hydration is one of the very important concern for aerobic endurance. So, here you can see glycogen breaks down to glucose to phosphoglyceraldehyde, then it converted to pyruvic acid oxidation of acetyl CoA. Even the fat can be converted to acetyl CoA and give you the energy through oxidative process, because the triglyceride is a major fuel which breaks down to glycerol and free fatty acid. Glycerol is in turn go to the aerobic pathway through phosphoglyceraldehyde, enter the glycolytic pathway. Amino acid, particularly alanine, then the amino acid like leucine, isoleucine, valine, these amino acid can be converted to through the process of gluconeogenesis and converted to acetyl CoA for aerobic oxidation. So we have our store for liver and muscle glycogen is limited, as I told you. So fat is much more bigger storehouse for our body. So a 70 kg person with a 12% body fat, the normally will get around 625 gram of carbohydrate, where 500 gram comes for muscle glycogen, 15 is glucose in the body fluid, and 110 gram are present in liver. So the total calorie, if you multiply this figure into 4.1, you will get the total calorie of this. The fat, obviously 1 gram gives 9 kilocalories. So you can see the fat can produce more ATP, definitely yes. The palmitic acid gives more than 120 ATP molecule when it breaks down. The fat as such, the storehouse also for fat is around 8 kg, 7.800 grams, which is close to 8 kg, and intramuscular fat is 161 gram. So the total kilocalorie in terms of fat would be much higher, but the only for beta oxidation process to continue, you require oxygen support. That's why when the oxygen is abundant, when you are working with a low intensity aerobic spectrum, then the fat would be a preferred fuel than carbohydrate, as I have already mentioned. The aerobic production of ATP occur inside the mitochondria and involve the interaction of two cooperating metabolic pathway, that is the citric acid cycle or the Krebs cycle and electron transport chain. So these are the process which is happening inside the mitochondria. So here is the Krebs cycle, where you can see the pyruvate oxidation process. Pyruvate is the 3 carbon molecule which is converted to 2 carbon molecule, which is acetyl CoA. Then oxaloacetate comes from TCA cycle. Oxaloacetate and acetyl CoA when mixed together, it forms the citrate. Then the citrate converted to isocitrate, then alpha ketoglutarate, then succinyl CoA, then succinate, fumarate, malate, and then convert to oxaloacetate. So there are different enzymes also responsible for this reaction to occur. Particularly the rate limiting enzyme for this Krebs cycle is SDH, succinate dehydrogenase, which is very important enzyme which regulate the citric acid cycle. So here NAD and FAD, these are the two carrier molecule which hold hydrogen, becoming NADH and FADH2, and then it goes inside the mitochondria through electron transport chain. The ATP is being generated. I will show you the details in figure, but acetyl CoA, then acetyl CoA in the Krebs cycle, carbon dioxide is formed because the carbon molecule is splitted off. Then the central hub of metabolism is the Krebs cycle and produces the precursor of electron transport chain, which is the NAD and FAD. So here you can see the oxaloacetate is 4, acetyl-CoA is 2, forming a 6 carbon molecule against citrate. Then the NAD is here is 1 NAD, and here 1 NAD, and here 1 NAD. Per pyruvate oxidation process. So 3 NADH is formed, 1 FADH2 is formed, and the GDP or ATP is formed here 1. So you can see the 3. If the entire glucose breakdown happened, the 2 pyruvic acid, 2 acetyl-CoA, so here it would be multiplied by 2. So the 4 NADH, here is 1 NADH, then 2, 3, and 1, 3, that is 6, and here 1 FADH2, then it will be multiplied by 2. So here is the process where you can see once the NAD is carrying the hydrogen, becoming NADH. So while the hydrogen is transferring through this process, then the electron is in these are the cytochrome system 1, 2, and 3. This is in this cytochrome system. Once the hydrogen, once the electron is released, then this hydrogen goes from inside the mitochondrial membrane, and it pushed outside. So 4 goes outside by 4 hydrogen ion goes outside with a single electron. At the expense of single electron. So 4, and 2 for 3 pumps. So the 10 hydrogen ion goes outside, and after that, once it goes outside, the concentration here is more. Once the concentration in this part is more, then that hydrogen again through the chemoosmotic process, then this hydrogen comes again back to the matrix, through the respiratory assembles, and in that process ATPase is activated, and the ADP become the ATP, and ATP is formed through oxidative process through chemoosmosis, and then these phosphate again ATP, once the ATP is produced, ATP goes outside the membrane to the cytoplasm in the exchange of phosphate, and the phosphate, once it comes inside, that also comes through a separate membrane carrier model. So the ATP yield and efficiency is the 36 molecule of ATP per glucose. Normally it is in the textbook, but recently but some of the new textbook shows it is 32, because earlier it was 1 NAD produces 3 ATP molecule, but later on it was revealed that 2.5 ATP molecule, and FAD earlier textbook it was 2 molecule of ATP, but now it is 1.5 molecule of ATP. So that's why there is 36 and 32 molecule the net gain, which is revealed in different textbook. As I have mentioned, in a lower intensity activity, the fat is a preferred fuel than carbohydrate. Carbohydrate takes over when the intensity is more, that has shown in the crossover model. Once we talk about the integration and application, then oxygen deficit obviously at the start of exercise. When we start exercise, then our VO2 would be around 3 to 4 ml per kg body weight, and it goes up to 5 4 to 6 4 to 6 liter per minute. So definitely once you start working with a higher intensity, definitely your you need to your system need more oxygen, therefore therefore your oxygen uptake will be facilitated. As the intensity is more, you require the more amount of oxygen to be breathed inside and supply through muscle to satisfy the metabolic demand of the muscle. So if you see here, this is the oxygen deficit, and this is the oxygen, this portion is called excess post oxygen consumption. So the oxygen deficit, obviously for the trained person, the kinetics of VO2 or the kinetics of oxygen uptake would be much faster rise compared to slower rise of the untrained. The faster rise because they have more oxygen uptake, better oxygen uptake capacity in a initial phase of the exercise. So faster kinetics allow less PC depletion to occur and less lactic acid formation. So that is the effect of training. The kinetic change of oxygen uptake do occur. So this is the oxygen deficit, and this is the excess post oxygen consumption or epoch. So oxygen deficit obviously would be higher if the intensity is higher, if the intensity is more. There are two phase. One is the rapid phase of decline or epoch, and the slower component is the delayed response and the rapid component. The rapid and delayed component is basically for the reason, if we wanted to reason it out, this is the reason. The oxygen debt or excess post oxygen consumption is influenced, number one, resynthesis of phosphocreatine in muscle, that is one. The second thing is lactate conversion to glucose. So oxidation of lactate, then restoration of muscle and blood oxygen stores, and the elevated body temperature. Body temperature become elevated. The post exercise elevation of heart rate and breathing, and there are hormone like epinephrine and non-epinephrine. Both the hormone is responsible for the metabolic release of fatty acid oxidation and the glucose breakdown. So these hormones also become elevated, and all this elevation, because of the elevation of this, there is a delayed kinetics of epoch in the later phase. The energy, duration, intensity and metabolic demand. The energy to run 50-meter dash, or to complete a single play in a football game comes principally from ATP CP system. The energy to run 50-meter dash, definitely the reliance would be ATP CP, but for football game the aerobic system is also one of the system which is important for playing football. Then anaerobic glycolytic system and ATP CP all together act. Depending on what kind of activity you are, when you are going for heading the ball, definitely ATP PC system is more prominent in football. When you are when a defender is or the forward players is going for a long run and running for around 60 meters, then definitely 60 to 60 meters, and it is repeated running, definitely the anaerobic glycolytic system would be the fuel for giving you the energy. ATP PC system can supply almost all the needed ATP for work for event lasting 1 to 5 seconds. Intense exercise lasting longer than 5 seconds begin to utilize ATP producing capability glycolysis. Energy to complete event lasting more than 45 seconds comes from the combination of ATP CP system and the anaerobic glycolytic system and to aerobic system. Intense exercise up to 60 seconds, 70% anaerobic and 30% aerobic. 2 to 3 minute 50% anaerobic and 50% aerobic. Long term aerobic metabolism is the primary fuel for giving you energy. Energy system interaction in sports, endurance predominantly aerobic, intermittent sports like team games, it is mixed system, and the power sports like shot put, javelin, then jumps, all jumps where ATP and PC system is the dominant. When we talk about, this is the energy system interaction in sports, which is quite obvious here. 100-meter sprint, if you see here also some around 5% is coming from anaerobic, and 90% is coming from is coming from weightlifting. Again around 10% aerobic, 10% around weightlifting. Here it is ATP PCR system is the major dominant system, ATP PCR. Here also ATP PCR and ATP PCR and anaerobic glycolytic system and lactic acid system. Here short put, the lactic acid system is very marginal, very small, but around 98% is coming from anaerobic system, ATP PCR anaerobic system. 400-meter run again is 60% comes from anaerobic lactic acid system, 20% comes from ATP PCR, and so it is you can see how the three system in combination working together for giving you the energy. So as the endurance is going more and more, reliance is on endurance for triathlon, then road cycling. So definitely the aerobic is more dominant, whereas the anaerobic PCR is dominant when it is high intensity sprinting activity, and when the sprinting activity lasting for 40 to 45 seconds, then the dominant energy system is coming from lactic acid system. So at last we are coming to the conclusion of the session, where we just wanted to give some kind of understanding about how to plan the program for the training, which is the essence of this particular topic. The training characteristics, duration, for if we wanted to load the ATP PC system, what kind of duration we should go for. 3 to 8 second maximum effort, intensity 95 to 100% maximum power output, rest complete recovery 60 to 120 second is the duration, and work rest ratio would be 1:6 to 1:12 depending on the periodized cycle and what are the particular sprint component we wanted to develop. That would be the key thing for planning the schedule. Specific training method, sprint starts 0 to 30 second acceleration, Olympic lift, clean, snatch, jerk, plyometric exercise, which is also depth jump and bounce, which can obviously improve the explosive power. The maximum resistance training 1 to 3 repetition, that basically once the repetition is number is less, then definitely our notion goes to develop power and explosive power. So the medicine ball and explosive throw. So these are the specific training method. The training adaptation, definitely once we plan this program methodically, it can enhance the phosphocreatine store by 10 to 30%, creatine kinase enzyme activity enhanced ATP store in the muscle, limited but obviously measurable. Then the fast twitch muscle fiber recruitment also increase, and the neuromuscular coordination and power output definitely will be enhanced. The second process is the glycolytic system, where the duration is 15 seconds to 2 minutes, intensity is 85 to 95% of the maximum effort, rest variable based on training goal, because sometime we used to go for incomplete recovery and sometime we goes to complete recovery depending on the periodized cycle. So, specific training method is a high intensity interval 30 seconds to 2 minute effort depending on what particular sports and what particular event he is engaged in. Repeated sprint training 6 to 10, 100 to 400 meters, circuit training with minimal rest, sport specific high intensity drills, lactate tolerance set, progressive accumulation of lactate. The key training adaptation which happen is enhanced glycolytic enzyme activity, which is PFK, phosphofructokinase and lactate dehydrogenase, which are essentially rate limiting enzyme for glycolytic pathway. Muscle buffering capacity enhanced by 40 to 50%, lactate tolerance and clearance rate enhanced, glucose and glycogen utilization efficiency has increased, and anaerobic power and capacity also increased. Training the aerobic system, duration is more than 3 minutes. It is a continuous interval training, intensity 60 to 85% of the VO2 max over the below the lactate threshold. The rest is the active recovery and short interval. The volume would be high, hours per week. The specific training method is the long steady distance running, which is the zone 2, tempo or threshold interval zone 3 and 4, VO2 interval 3 to 8 minutes at 90 to 95% of the VO2 max, that will restore the maximum oxygen uptake capacity or VO2 max. Polarized training 80% easy or 20% hard, and cross training swimming, cycling and running. The key adaptation, mitochondrial number increase, mitochondrial size increase, which is called mitochondrial density, which is increased by 40 to 50%, oxidative enzyme activity, all the oxidase, cytochrome oxidase and the other oxidase enzyme activity enhanced, capillary density and blood flow increased, cardiac output increase and stroke volume increase, and fat oxidation also increase. So, the take home message is the ATP fuel for all the activity. The energy system are integrated, not isolated. Training specificity enhance adaptation and performance.